Well, it's okay. Welcome to the June 6th, 2023 session of Tangerine SDR and Hamside Technical Session. My name is Dave, KV0S, and in the 3 weeks that we've been gone, I went to Dayton Hamfest, worked in the Tapper booth, got to see many of the faces here in person. I did get when I got home, I got a KA9Q radio working and with the RX888, and now I have it working with AirSpy HF as well. So making progress. I've been collecting whisper data and listening to WWV all 6 frequencies at once, which is interesting. You can actually hear slight differences in the times just in the audio. So that's it for me. Next we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks. It has been absolutely crazy busy for me. I have also gone to the Dayton Hamvention, and then of course we had offer Memorial Day, and then this past week I was in Boulder, Colorado for a Living with the Star workshop, and I took 3 students out there and my wife, and we all presented or participated in the workshop, and that was to look at traveling ionospheric disturbances, and included some of the large-scale amateur radio traveling ionospheric disturbances in addition to the medium-scale ones. But I think, when should we make the announcement about what we're doing with the Tangerine, Dave?
Whatever you want to. It's up to
Okay,
you.
so I guess I'll say it now. So while we were, I think everyone on this group knows that we've really been struggling with the FPGA on this Tangerine SDR project. We've really been struggling getting this data engine going, and there's a whole number of reasons for it, ranging from difficulty getting parts to, where Tom McDermott has had trouble getting the timing to work right. You have to use this proprietary, very expensive Fortis software, so it means the project's not entirely open source. So it's really been a struggle with that. And allegedly the grant is ending in December, and so I've been losing a lot of sleep over this and trying to figure out where to go with it. So when I went to Dayton, Ohio, Rob Robinette has been diligently looking for a replacement for the Kiwi SDR since they're not available anymore. And he remembered Phil Karn KA9Q's approach to doing the software-defined radio, where instead of relying on an FPGA to do the digital downsampling that's required, he's able to instead use this fast convolution method, and he is able to basically create an arbitrary number of slice receivers with varying bandwidths and using high sample rates, and he's able to process this all on a conventional CPU. So it doesn't require an FPGA or a GPU or something like that. And so after talking with Rob and with Dave KV0S and with Phil and with a number of other people, we came to the realization that the way that we should move forward on this Tangerine SDR project is not to keep going with the FPGA data engine, but instead to take the clock module that we've already designed and produced, and the RF module that's already been designed and produced, and come up with a good USB interface card that can just put those samples onto a conventional computer over USB 3. And then we're going to use Phil Karn's approach to do the processing on the conventional CPU. So we've we've been in touch with Scotty about all this. He's fully supportive of what we're doing here. I have a couple of students and our research engineer at the University of Scranton, Majid, he's helping out with this. And we have a number of people on this call, including I see Franco's joined us and Rob is on here tonight.
Yes.
And a number of other people who are doing this sort of thing. And what's really great is that there's these fairly inexpensive Chinese software-defined radio receivers called the RX888s, which can provide up to 64 megahertz of bandwidth over a wide range of frequencies over USB 3. And so Rob has already gotten this to work with the KA9Q software, and then Dave has as well, and a few other people. So there's already a proof of concept. So that RX888 is a really good start. It's only $200. It doesn't have the same level of precision time stamping that we want on it, and it doesn't have a lot of the features that the RF module that Tom has designed. It doesn't have that, but it can at least proves that what we want to do is achievable, and now we can go ahead and make the interface board with this. Did I leave anything out, Dave?
Don't think so. Not
Yeah.
at this time.
Okay, so I think so what Tapper is going to do is Tapper is going to work on designing and producing the interface board for this, and then the University of Scranton's students and Majid are going to work on adapting this software and basically making it look like a new Grape version 2. And so we'll have for the personal space weather station application, this thing will be able to do, you said you were able to listen to 6 slices of WWV, Dave?
Yes.
Yeah, so basically this will become a Grape that can do 6 slices simultaneously, and
Yes.
then of course much more, but that's just the starting point, and that'll at least bring us to closure with this particular part of the grant, and then we'll be able to move forward. So and that's where we are now. We're working on executing that plan. So back to Net.
Yes, and I'm going to go ahead and make a roll call, and I would like it if people don't go too long, because we have a lot of things to discuss after we go through the roll call. So next on the list is Bob N5BRG. Go ahead, Bob.
Yeah, hello, everybody. Good to hear all this exciting news, and just checking in tonight. Anxious to hear from Dylan and see what he thought about the Hamvention, being a young fella, and I think in the first time he was there, and I wanted to hear if he got his car running that he needed to drive up there. Anyway, back to you, Dave.
Yes. Oh, and I also wanted to mention something else I did in my spare time is the Tapper recorded Nathaniel's AMSAT Tapper banquet talk, and the talks of John Ackerman, myself, Dylan, and Michael Osman, and those are all posted on the Tapper YouTube location. So if you weren't there and you would like to go back and watch them, or if you were there and you want to see them again, they're up, and we don't have normal YouTube numbers. I think we have 100 views right now.
Oh, and one other really big announcement. I think most people might know this already, but NASA did select the Solar Eclipse QSO Party grant for funding. And
very good.
And this is actually a really big deal. There were only 35 proposals submitted to the call, and they only selected 5.
Oh.
So yeah, so it's 14% success rate. And I heard we actually beat out MIT Haystack on one proposal.
Oh,
so.
You'll have to point that out to
Phil is the one that Phil pointed it out to me.
Oh,
actually.
okay.
He's the one that told me this. And but the reason this is most important is Gary made up these really nice cards, and the bottom of it says a NASA supported citizen science event, and we were passing these out at Dayton. So now that we know that the cards are actually true. So
Yes.
that's why, that's the most important reason that it's good that this is funded. So,
Okay, next on the list, we have David Witten. David, you have a comment?
Um, not a lot. I went to Dayton, but otherwise just been puttering away at the usual things. Nothing else to report.
Okay, next on the list, we have Robinette.
Oh,
Comment?
good. Oh, goodness. Okay. Hello, everyone. I'm very excited about this. I'm glad to see that the level of support for this this project, or the USB interface. We're looking forward to it. I have Phil and Franco, who's with us, have been working on the drivers for the RX 888 on one that's I've installed out at KFS. So we do have one running, and that system is available for others who would like to start developing in their application programs, like the GRAPE application. If they want to do development work, that I can make that that system, RX 888 and a host computer, I can make it available to anyone who wants to do development work. And the architecture is really quite nice in that, some different developers, I think, can largely work without interfering with each other. I mean, Franco, I think you're pretty well done with the driver part of that, although I'm sure there'll be, yeah. Although I think there may be some driver enhancements we may find we want, but the system, I think, is up and very stable. So we don't have to wait for this USB Tangerine. You can start your software development work, I think, right now. And if you want to do that, please contact me, and I'll set you up with an account. And I'm starting to do that work myself. I'm trying to start this week to actually interface my Whisper Daemon program with with the K9Q radio and the RX 888. But others can start their work whenever they're ready. The system is there and will be there, and it's seems quite stable. So I think that that would, I hope, encourage people to start work on their parts of the project in the coming weeks, rather than waiting for months for something to be available from the Tapper SDR. Everything I believe that you do now will be if not almost invisibly, if not completely invisibly, transferable to the Tapper implementation. So I think this is one of the advantages of this approach, is that all of the development work that was based upon SDR reception can start now.
Yes.
Anyway, that's my message to the group.
Okay, I do want to let you all know that Rob will be giving a talk at Friedrichshafen later in June, and on some of his work. And so I saw the announcement of the talks available, and it is online. So those who don't want to travel to Europe right now, you can watch it. I think Phil Karn said he was going to go and watch it in person. So
there's a whole host of people, including Phil, who are going to be attending that convention. And I'm not sure my presentation is of particular interest to this group. It's about, well, I'd hope it is. My presentation is focused on how you can create a WWV of your own using really inexpensive components. The RF0 single board computer and the QDX a 5-watt transmitter. So that's my point. But the real science work is coming from Gwen G3CIL, who has a presentation showing how you can determine a path of of a received whisper spot. And there's some pretty amazing stuff based in part using Farlap. So he showed me, I don't know if you've seen this, Nathaniel, but Gwen showed me some work he's done recently on that using the Farlap to identify the locus. Anyway, I won't go into the details, but Farlap was part of his presentation. So
Yeah, he sent me a report this morning.
oh, good. Okay, well, it was
There's
new to me, and
also-
Starlight.
There's also a very interesting talk by a guy named Lawrence Barker, who has followed on after the Open HPSDR people. So I want, it's some interesting new developments there. So let's go on down the list. And next on the list, I've got Michael, AAK. Comment?
Thank you. Greetings to everyone listening. Back to you, Dave.
Okay. Next on the list is Bill Engelke, AB4EJ, right?
Yeah, you got it. You got it. Yeah, attended Dayton. Just getting some reservations in place. Got reservations in place for Cedar as well as the Huntsville Ham Fest. My great system had been down for a while because oh man, my internet service was out for days. It took AT&T climbing up poles to fix it. Anyway, so got that back up and running. I resurrected the software that does plotting of the great DRF data, and we'll discuss that with Kong tomorrow. And also spent some time looking into how to produce HDF5 files, because we will be needing to produce HDF5 files to push to the Madrigal system. And just a variety of other things. But I see I've got some homework to do on learning about the RX888. We talked about it'll run on a conventional computer. Oh, and we're not talking about are we talking about what are we talking about, a Raspberry Pi or an Intel desktop? So some of you tell me what we're talking about here, but anyway, we don't need to go into that. I suppose I'll learn. Anyway, that's back to net.
Okay. It has drivers for Windows, and thanks to Franco here, we have drivers for Linux. So let's go on down the list and let's see, Bill, N8ET.
Yeah,
It's been a while.
yeah, it's been a while. I don't know how many months, but I missed Dayton for the first time since about 1974 this year. It was our 50th anniversary, so I figured I'd better go where the wife said this time instead of to Dayton, and went on an Alaskan cruise. So I was out of touch for a while. Just got back. My computer's been down for 3 weeks while I was away, and the hard drive went west. Finally got that back up and running. I'm sort of reconstructing things on it now, and it's coming slowly. The other big event in the last several months, I finally got a hold of a Flex 6400. So I've got that here on the desk, and that's kind of neat. But since the hard drive went, I don't have any software for it right now. So right now it's just a black box that's sitting on my desk. And someday I'll get back to that when I get to the point where I install Windows back on the computer and get it on the segment of the hard drive so that I can run the software and see what's going on in the bands again. But trying to get dug out from under. So that's about it from here. Oh, the other thing, CBJ is on here tonight. He's a friend of mine, and he's sort of interested in what's going on here. It's his first time on, so give him a shot when he gets a turn. So
Okay.
back to you, Dave.
Yes, well, CPJ is the next on the list. Go ahead. Do you have a comment?
Looks like he's disappeared, but
Okay. He's still in the participant list, so maybe he's
yeah,
just
he's still
listening.
up there. He went on mute.
Okay. Next on the list is Dan in for XWE.
Okay,
Hi, Dan.
thanks, Dave, and good evening, everyone. Enjoyed Dayton, enjoyed meeting with everyone. A couple of comments about going the computer route as opposed to wrestling with the FPGA. I really don't think we're going to be able to use single board computers with this. We're going to have to look at something a little bit more powerful. I've done a lot of work with the Raspberry Pi the last couple of years. And one of the things that really doesn't handle very well is USB 3.0. And that's not unique to the Pi. Most single board computers do not. All of them that do not use PCIe for data transmission internally have a heck of a problem with high data rates. So anyway, we'll see how it works out, but I think we're going to have to look at a different CPU or different class of CPUs if we head the direction of a radio and software as opposed to an FPGA. Anyway, back to you, Dave.
Yes, and one of the interesting things is Phil's code lets you put pieces of the radio on different computers, which is it takes a while to get your head around, but it increases the performance if you have a nice network in your. It has to be a wired network in your house or in your office. Next on the list is Dave McGaw in 1 HAC. David, are you there?
Yeah. Hello, everyone on the net. Yeah, of course, the big thing over the last few weeks was getting to Dayton and passing the message on about HamSci events, and also finding a few things. I picked up a cheap rubidium for $50, which was cool, and also was inspired to get a TangerineSDR to give that a try, because we do various direction finding things around here. Sometimes benign and sometimes not. Yeah, I'm interested in we were talking about this new direction. I do hope that we don't totally orphan the existing hardware, because we've put a lot of effort into it, and I can't believe that we can't find some solution to make it work. But hopefully we can get it to work with the free software, not have to put all the money into it, as Nathaniel was saying, for proprietary software. But it is a great idea, however we can get data coming through. And anyway, more shall be revealed. And we certainly hopefully we get something significant running by October. I guess that's about it. Back to Net.
Yes, the main point here is to help Nathaniel meet the specifications of his grant in the time that we have left. And the intent is to continue with the other hardware as we can get it working.
Yeah.
Next on the list, let's see, where am I? Dylan. Dylan, are you there? I don't know if Dylan's there. I saw him a little earlier.
Yes, I am here out of the depths of hell. Have I ever stated that I hate American engineering?
Well, I don't know.
Yeah, Chevrolet is why.
Oh,
So just here working on a truck.
okay.
Yep. Doing good. Really loved the Dayton Hamvention. It was super fun. Had a lot of cool experiences, a lot of awesome learning experiences, and a lot of awesome deals I got from the flea market. So it was absolutely amazing. I would definitely go again. I would definitely want to speak again. And I loved it. But yeah, I got that car going, luckily. Just barely actually. It's back in our shop again. It has a couple sensors that went bad. Well, I guess for the sake of time, I'll send it back to net control.
Okay, well, and we appreciate you giving a talk at the Tapper Forum. So thanks so much. And next on the list is Franco. K4 VZ.
Hey, good evening, everyone. My name is Franco Venturi. Quick introduction. I've been working with Phil for probably the last few months on this RX888. And we basically were able to run it on Robinets and a couple of more or devices like that. And when I read the message from Rob and then from Dave, whatever, I had a couple of comments that if you have time, I'm gonna make quickly. The first one is I look at the current TangerineSDR, and it looks like the idea from Tom, I think, was to stream in parallel to ADCs at 122.88 mega sample per second. And I did some quick math, and I don't think that kind of throughput is possible through an USB 3, even at the highest speed, at least from what Cypress says. So that's the first comment I want to make. The second comment is that I think Rob Robinet was thinking about adding some timing information to the stream, probably similar to what the Kiwi SDR does. And I don't know exactly what is the idea of that, or if it will be a different connection to the same board, that kind of stuff that I'm not sure. Then a couple of comments to the question that were asked, I think, by Bill earlier. The big part of Phil's program is that at the very beginning, there's a huge FFT transform, which basically is the number of samples that that you collect in the 1 milliseconds interval, which in this case is probably 2.5 million or something like that. And that is what is going to kill your is going to be the biggest burden. He was able to get a good performance on an Intel computer. I forgot what he has. I think it's an i5 because he uses the software.
Almost.
Keep going.
Okay,
I think
sorry.
somebody had an open mic.
Yeah, I just muted him. Go ahead.
Okay,
keep going,
just
Franco.
1 second, I'm done. Because he has an i5 and he was using the software called FFTW, which is a fast Fourier transform of the West, whatever, as he was getting some performance. Once you get past the transform, then everything is much easier because for each channel you want to do, like if you want to do 25 WSPR channels, you get only a 12 kilohertz kilo sample per second higher inverse FFT, which is not a big deal, so that's basically the bottleneck there. I also was looking in other ideas, and again, I think someone mentioned the Raspberry Pi and limitation. And the Raspberry Pi, by the way, these days is almost impossible to find, at least the version 4, or if you find it, it's probably $100 or so. There is another interesting board called the NVIDIA Jetson Nano, which seems to have also a GPU, so it could be useful for that purpose. I don't know if you guys have thought about that, and I saw they say $440, so it's not too bad. That's another option that could be considered. And I think I'm done, and I'm sorry to keep it so long, guys.
Oh, no, you've got interesting stuff to add
And
to our
again,
conversation. And
back
thanks
here.
for your help getting my radio up and running.
Yeah, anytime, guys.
Yep.
Just a brief comment. I agree with Franco that the Raspberry 2 RF board is unlikely to be able to be both channels, I think, well exceed the bandwidth of a single USB 3. So I think that if you're going to build such a board, I suspect that both you're going to have two almost independent USB 3 controller chips and connections to a host computer. And of course, we have to find a host computer that can swallow. Yeah, they have to. It has to be, the host computer has to be appropriately, but architected, the USB interface section of it. So I think that's an area of investigation. And I think you're running right now at KFS. I'm using an i3 7500 to fed by the RX888. I think it's only sampling at 66 mega samples, or yes, I think is that right?
64.8.
Yeah.
64.8.
Okay, well, in any case, it's consuming perhaps 30% of the i3 CPU bandwidth. So that might give you guys a sense of how efficient in terms of CPU utilization this architecture is. It's remarkable that an i3 can swallow that whole 30 megahertz and of the bandwidth and generate, I think it's generating 30 or more output streams, and yet it's only 30% busy. So
Yeah.
You're right that the Pi 4 is not a good candidate for this as a for this architecture. I think Phil has had his software running on a Pi 4 for a long time, and is able to do 200 channels of 10 megahertz wide bandwidth on it. So, but I think our interest would probably exceed the capabilities of the Pi 4. But I think there are many, there seem to be other alternatives. I've recently been working with an Orange Pi, which is significantly more performant than a Pi 4, and it is available in quantity. And I think it's a pretty well-established product line. So it's $80 or something for this thing. And I'm shipping off some equipment to test that Orange Pi. I don't have one of my own, but that seems like a candidate. Back to the net there.
Okay.
If I might make two quick comments. One is that if we're using the FPGA as intended, it reduces the sample rate that actually has to go to the host processor.
Right.
Secondly, I'll just mention that to replace the Pi 4s that we've been using NUCs, which seem to work pretty well.
Yeah. Next on the list is Gary, AF8A. Go ahead, Gary. Is Gary there?
Yeah, I sure am, Dave. Just want to say good evening, everyone. Nice rubbing elbows at the Ham Fest, and we'll turn it back to Nut.
Okay. Next on the list is Hyomin Kim, KD2 MCR. Go ahead, Hyomin.
Hi, good evening, everyone. So as Nathaniel mentioned, we were in Colorado to attend a meeting that was led by University of Colorado Boulder. Yep, we gave a presentation. Also I was thinking about worrying about proposal submission, which happened. Nathaniel was part of our member. If that's funded, then the NGIT, MIT, University of Scranton, University of New Hampshire and University of Florida will supply, modernize the geospace instruments that have been operational at South Pole State and McMurdo Station. Some of the instruments are aging, so the main theme of the proposal is to upgrade those aging systems. So I've been working on that, and now it's done. The second thing that I wanted to share with you is the user interface for the magnetometer system. So if you allow me to share my screen.
Hey, go ahead, Hyomin.
Yeah. So it'll be quick. So I guess you can see the personal space weather station central control system. Do you guys see this?
Yes.
All right. So this is the data portal user interface that one of our students has been working on from NGIT, collaborating with students and Bill Enkelke at University of Alabama. This is the data are basically archived and processed in the server system run by University of Alabama, and my students has been working on this user interface to further process and plot the data so that we can take a look at the data pretty easily. So it's getting its shape now. We're still working on some fine tuning, but however, I can see that the plotting tool is quite close to being done. So this is the interface that you will see. Of course, the website is not public yet, but basically you can specify date, start date and end date. You can put date and time. So basically, I want to show you December 9th last year. The first, I don't know, this is 12 a.m. to 11:59 p.m. And we have, so far we have 7 stations. For now, let me click on Nathaniel's station. In this map, you see the stations that are currently reporting data. So I believe, oh, okay, I forgot this. Probably if you click, then one of these, labels should change the color or something. But I think, Nathaniel, you're here, right?
Yeah, I'm right there.
Yep. So if you click this, or you can select all. However, I'm not going to do that because I think some of the data are still not reporting proper data. But the functionality is still here. Now I'm trying to select Nathaniel station and plot data. Then the message is here. I think this is something that we still work on, but it was working properly. Oh, what's going on here? Let me try it again. I don't know what's going on here.
Yeah.
Yeah, there's a message that says waiting for Mapbox. So
Okay.
maybe it's a good internet connection. On the lower left, it says waiting for Mapbox.
Okay. I guess even in the afternoon today, it was working perfectly. It was showing plots and you can zoom in and zoom out and everything. So most of the
Maybe
functionality was there.
running it with the Zoom session or whatever else you have running.
Yeah. It is still loading. I don't know what's going on. So maybe I lied. Or my student and I had a discussion this afternoon. Maybe she is still fiddling with the system or not, whatever. Because I gave her some other ideas about making this plot look nice, make the plot look nicer. Anyway, so basically the plan is to show data here for each station so that you can see 3 components in one panel. Then depending on the number of stations, so if you choose 2 stations, you will see 2 panels. If you choose 3 stations, then you'll see 3 panels. In each panel, you'll see 3 axis component so that you can see the entire structure, entire magnetic field variations. I don't know why this previously, when I was testing this, it was pretty fast. Last time it was really slow. One reason is that according to Anderson, as soon as you try to call the data, then the server tried to call the entire data set and load it into the data server and try to plot it. So it took a while, but they have already figured it out how to resolve this issue. I guess one solution was to sort of like a down sample the data only for the plotting purpose. So it was pretty instantaneous when I was testing this afternoon. I don't know what's going on. Anyways, that's the update. Maybe I can share.
Can I, Hillman, can I suggest that you, like tomorrow or when it's working again, you take a screenshot and send it out on the list?
Sure. Yeah. Okay. So, yep, that's all I have to say. Back to the net.
Okay, next on the list is J, WB8 SBI. Go ahead, Jay. Jay there? Well, we'll go on. Joe, W7 LUX, are you there?
I sure am. Good evening, all. The grape keeps plugging away and the signal strengths are significantly less, but then we're seeing a lot of problems on other ham bands too. And that Kraken is a pretty interesting gadget. A friend of mine has one and he's just absolutely delighted with the results he's getting from it. And we're getting rain, rain, and more rain here. Back to you, Dave. Thank you.
Okay. Next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. It was nice to see everybody at Hamvention. And it was also nice to see there were some interested people in my VLF talk. There was even somebody from the VLF groups.io group at my VLF talk. So that was very nice. And then a week later, I went to Austin, Texas for NI Connect. That's the conference for National Instruments. And I hate to admit this, but I kind of had more fun there because there was quite a lot of toys to play around with. One of my interests is in test, and it was that was a lot of fun. I also I was talking to Phil Karn. It's always good to talk to him. I feel that every time that I talk to him, I always learn something new. So I was telling him about VLFRX tools, about the work that I do. So I sent him an email. I was talking to him about a post from the author of VLFRX tools a couple of years ago. Lightning struck the UK power grid. So with his VLF receiver, he was monitoring the power line frequency 50 hertz. And at the moment that the lightning stroke occurred and hit the power grid, it reduced its generating capacity for that moment, and the frequency went down due to the increased load. And by using that, he was able to he's confident that he was actually able to identify the actual spheric that came from the lightning stroke that damaged the power grid just for that moment. So I wrote up a email for Phil about that, and also about VLFRX tools. I have also been trying to introduce K and IQ radio to the amateur radio astronomy community. Lots of very good people there too, and I see K and IQ radio very powerful with amateur pulsar astronomy. So I would like others to actually others in the community to see his software and contact him about different applications for example, converting the IQ data from a pulsar observation into the standard filter bank format that is often fed into Pulsar programs like Tempo 2. So I would really like this to kind of streamline and make Pulsar observation much easier. And with his wonderful software, I think that's absolutely possible. And also one thing that I wanted to remind everybody, everyone's talking about these, you know, that you know, for the Tangerine USB interface board, you know, that we might need 2 USB 3 interfaces. But I wanted to remind everybody that the actual capture application can run on a computer with the appropriate USB 3 ports. And then from there, send over a network to other computers through a multicast group. And you could do your processing that way with you know, without any trouble. So you could have your one single board computer that could possibly capture all of the data, and then you just use other computers on your network to listen to that multicast group. That's very similar to the principle of VLF-RX tools. In fact, the full VLF spectrum coming from my Raspberry Pi system at Nathaniel's house is also written, or is also sent over over his local network to a VLF server that we have running. So this is kind of the same thing. So then I could take data from that VLF server and also stream it to mine. So that's the same principle with Phil's software as well, except he uses multicast. You obviously need a switch that supports multicast. They tend to be a little bit more money, but in this case, it would definitely be worth it. And so lastly, I was talking with John Ackerman. He was kind enough to work on the VLF receiver board, the one that I use at Nathaniel's now, but he was kind enough to actually work on laying out a PCB for it to kind of productize the VLF receiver and make it easier for people to build and set up and in their backyards. So I'm kind of excited to see what he comes up with, and I would like to test it and actually get this going as a kit. That's all I have. Back to the net.
Okay, next on the list, if he's still there, is Nabin. He's coming to us from Kathmandu.
Hi,
Are you there?
hello everybody, and Namaste. This is my first time in this Telecon, this meeting. So I'm really proud to be proud. I feel very proud to listen to you guys, all this interesting stuff. This is what I was craving. I am craving for, you know, all this scientific stuff, very advanced stuff, new things. So I've just started. I have just started in to learn about these projects, about this personal web weather station and these SDR dongles. So I will learn more about the projects in coming days, and hopefully I can help you in programming or front end or back end at the beginning, and later when I understand these hardware things, then maybe I can also help with setting up hardware and reporting to you guys. So I feel so good, you know. So thank you for inviting me to in this group and accepting me in this group. Thank you. Back to you, Dave.
Very good, and welcome, and please come back.
Yes, sure.
We welcome your participation.
Thank you.
Next on the list is Tom in 5EG. Go ahead, Tom.
Oh, good evening, Dave. been busy trying to get the receiver module working and made some progress. There are two pretty big issues with the Neo software build environment that sometimes make the object code not resemble the source code. And the debugger tells you that it's the source code and the object code is different. I found out how to work around those issues and been able to talk to the SPI registers on the ADC chip. I'm using it in the CMOS mode now, putting out two parallel CMOS buses. The chip has a register where you can program the output CMOS drive strength. I had to boost that all the way to maximum to get 2-volt logic levels out of the part. There's turned out to be an error in the data engine adapter schematic that swapped the clocks. I'm getting one clock with good levels. The other clock, which is just wired to another pin on the ADC, puts out really bad logic levels. And I took the receiver module off the data engine adapter, put it back on, and the levels about doubled from 200 millivolts to 400 to 500 millivolts. And that almost kind of sort of clocks into the FPGA, but not quite. So I think we have connector issues, and I've cleaned the connectors with deoxit and reassembled the module a couple of times, and I haven't had a chance to get back and check to see if I can get real CMOS logic levels on the data interface out through the connectors. So a lot of hours in the last couple of weeks, but at least we're finally starting to clock samples. They're all wrong, but the samples are starting to get clocked out of the receiver. So back to the group.
Well, that's where you have to start.
Yeah.
So, and last on the list, we have Zoltan, KD8, ABX. Are you there?
Hey there, how you doing? My name is Zoltan. I've met a handful of you in Xenia a few weeks ago. I'm an engineer. My first love was particles and plasmas. I'm really interested in citizen science ideas. So at this point in time, I'm going to sit back and hopefully not get in anyone's way. And if there's some room for me to help out, I'll jump in, or you'll jump in and let me know. So thank you very much.
Well, we're always interested in any kind of technical help you're able to provide. If you have any of the skill sets that you hear us discussing, please jump in there and please come back.
Thank you.
So I think I've called on everybody on the list.
Did you get Anchor Tayagi?
Did I? Oh, no, I didn't get Anchor. Anchor, are you there?
And you didn't get AA0ZZ, who's CBJ.
CBJ was off the air for a little bit. So you have a comment?
Hi, sorry, I was mixed up there for a while. I'm Craig, AA0ZZ, as Bill said. He introduced me to this group just this afternoon or this morning, so I'm just getting my feet on the ground and seeing what you people are up to, and just getting some ideas. I'm an electrical engineer. I love building and experimenting with radios and wanting to get into SDR radios and so on, mostly for the ham bands probably, but I'm interested in some of the techniques that you guys are using. So that's about it. Thanks.
Well, we're all about the synergy between ham radio and atmospheric science. So we're trying to figure out, and we have something to learn from each side of that.
Good. So thank you.
Nathaniel, do you have any comments to bring us back around?
I think these were all really good comments. I'm very interested in how we're going to move forward with Topper developing, say, a USB interface board, what that's going to look like, and then of course, you know, how I think that's what I need to figure out from this group. What's the forward progress on the hardware side of things right now.
Nathaniel, I talked with Scotty last week, and he said that he might have the time to do a USB interface.
Okay.
He could only do the hardware. He can't do anything else. But he said the hardware part for him is easy.
Okay.
And I think that's pretty true. So, I would take it up with him and see what he's interested in doing and what he will commit to. I know
Okay.
that if he commits to something, at least in the short term, like, next few months, he'll follow through on it without question.
Mm-hmm. That would be very
Yeah.
good.
When I talked to him, he sounded generally enthusiastic about the idea. He still intends to continue on with the original Tangerine. So, and really our biggest problem is dealing with the this combination of the Verilog, the Verilog in the FPGA and getting the timing right, and the fact that we're dependent on a TCP stack that's running on NIOS, and getting those to sync properly with timing is the hard part.
Mm-hmm.
Because basically every time you recompile it, the timing starts all over again. Yeah. You can't fix, that's what Tom was telling us, is it's difficult to freeze apart in the current tool chain that we have, a part of the code.
I think I already have one of the development boards, the appropriate one for that, at least for the Cypress USB 3. It's wending its way across the ocean from England. I couldn't get one anywhere in the US or China, or they wouldn't sell me one from China. But they're not so difficult. I'm not quite sure I understand what's going on between the USB 3 component and the raw data coming out of the board, and that needs to be better described. I think it'd be easier to tell when we have some of these radios in hand. Also, the Pi 4 does use a single lane of PCIe to support its USB 3. And so if it has difficulties keeping up, it's probably just the CPU. There are lots of other post-COVID devices like this one is it's a Rockchip RX, or I don't know, this is a Redax Rock 5B, but there's lots and lots of these that have the Pi style GPIO interface that is useful for some components of the project. They almost all have that, and they almost all support lots of PCIe now. It's only the Pi 3s that completely and utterly do not have any.
Okay. I think we need to take a little bit wider view of things as well, because the operating system is going to be important, and not all single board computers have up-to-date operating systems available for them, because they tend to be specific to particular models of the board rather than just usable by any single board ARM core board. So anyway, I'm certainly not against moving on from the Raspberry Pi. I did notice one thing in the one that I have. When I run USB 3.0, I have an NVMe solid state drive for it. It runs really hot. Normally
that's the NVMe card that you have in it.
No,
the Pi runs for
the card is separate.
the Pi runs hot.
Yeah, the Pi runs hot. I mean, like
Oh,
really.
okay. Okay, yeah, I'll go along with that.
Yeah, I have like an NVMe adapter dongle, for lack of a better term, that interfaces to the Pi with USB 3.0.
I have, that's pretty hard
Oh.
to see, but I have some of these, they use
Move
Pi
it in front of your
CM4s.
face.
Yeah, it's hard to see. These have Pi CM4s. They don't have USB 3 output on this one because they're using it to run an NVMe drive. So these each have half a terabyte of storage on them, but they run very cool. They have a little fan that you can just barely see or feel. But I have no idea what the throughput performance is on on these things. But it would be nice once I have a couple of these radios on the way, and once they show up, I'll try and get some sense of how cross-compilable some of this stuff is and what kind of loads we see on different single board computers. If that is an appropriate strategy, I don't discount the idea of using, i5s or i3s or something of that sort too. Also, there are many variants now of the what you call it, the NVIDIA Nanos, and the Nano is not as efficient as some of the others like the Xaviers and the what the other one, but they don't have as closely coupled GPU with the ARMs, but they are very much more powerful and not terribly expensive, some of them. And I have those. I can do some testing on those as well, but they certainly can do FFTs. If they can't do anything else, they can do FFTs.
Yes.
Yeah, that's what matters. So I was looking, the Nano, it sells for about 150, the smallest model, which is not too far from a Raspberry Pi now that you can get for $100 or so. So that's my first comment. The other comment I want to tell to Rob that if you put two FX3 or two USB ports, then you have a problem that is very hard to synchronize it to streams. My idea is that if you want to use two receivers, the idea would be to send I1, Q1, I2, Q2, and so on. If you have two different ports, it's not as easy. On the other hand, if you only want to listen to, say, up to 40 megahertz, so you need a sample rate of 80, it's still capable of that. You just cannot go all the way to 122.88, but if you stay at 97.2, which is 64.8 times 3.5, then you can do that. And again, I got about the NVIDIA, there is a fact that they already give you something called the CU FFT, which is compatible with FFTW, so it wouldn't be too hard to port Phil's program to use that because the codes are the same. One last comment. One other interesting talk I saw at Friedrichshafen is the one about Maya SDR. I don't know if you saw that, Dave, by
Yes.
Daniel Estevez, I think. And it looks like he's able to run in FPGA, so that's the idea I was thinking, and he's able to program it in Python with something called Amaranth. So that could be an option because Python is much easier to use than HDL. Is FPGA, is Zinc, so I don't know if the same as the Max 10. I mean, if it's compatible by something, we could look if we decide to stay on the FPGA route, possible an option. Yes. Also, is able to do a 4096 FFT point on the FPGA, so that's pretty cool.
Just one comment, Franco, about the synchronization. I think that a number of applications are looking to synchronize more than two receive channels. So the Tangerine in and of itself with a dual input wouldn't satisfy those requirements. Phil has suggested that if there were a way to inject a signal, a stimulus into the RF inputs of all of all of the devices, all of the Tangerine or whatever the ADC at the same time, that since he's already examining every sample, if there were a periodically injected stimulus, he could find it and from the incoming streams, his software could find it and use that to synchronize the samples. That of course assumes that there's the subsequent samples, there's no error loss, or at least no unidentified error loss in the transfer from the FX3, the USB 3 chip, to the, or really from the analog to digital converter through to the main memory. But if that channel from the ADC output to main memory has no errors, or at least known errors, then Phil suggested that he could add a feature to synchronize the samples between multiple incoming streams. So I think that there is a path where we could take an RX-888, just the current design, and get a synchronized multiple input receiver out of it. And if that could be done, I think that's certainly worth exploring. And I know that Phil is interested in exploring it, and his interest is also crucial. So, but
Rob, has anybody talked about how to hook up a GPSDO to the RTL, or rather the RX-888, because it doesn't have you'd have to solder something to the board. It looks like that there's no connector for it.
There's no external connector, but there is provision on the board itself internally for external clock input, and an easy way. I think it's a jumper. I have an open mind, but I know that Glenn N6GN has opened his and said that the modification is very simple. I mean, you just need a a SMA pigtail from the, or I think it's one of those UFX, little tiny little, you even have a USF connector on the motherboard of the 888. And he has successfully used an external clock with his 888. So that so far, Glenn is the farthest along in testing this, and there's, so we're not to the point of full certainty of its performance, but so far everything that we hoped we'd be able to do with the 888 seems to be well within the possibility. So for Tangerine SDR kind of applications, you probably want to have, I mean, I don't like opening up and soldering on motherboards, but it seems like we could recruit somebody, if only within perhaps someone in the Tapper organization, or through them, find someone who would make such modifications so that we could make such modified and externally clocked 888s available.
Yeah, the documentation says it wants a 27 megahertz clock. It will take that. You can configure it to take that from an external clock. So
yeah,
Leo Bodner will put that out if you configure it right.
Yeah, you can. You could drive it. Yeah, it requires 27 megahertz, and as Glenn has observed that the input to it is the crystal, one of the crystal input pins. So the actual signal levels, optimal signal levels, are on the order of a few hundred millivolts, as it turns out. There's apparently a lot of subtleties that I wasn't aware of about running an oscillator, that if you power the crystal too much, it starts to shake off little flakes and changes the frequency. So there's a whole state machine apparently in the 5351 just to deal with the operation of the crystal and keeping its oscillation frequencies stable and continually accurate. He was startled by the stability and accuracy. He said it was approaching part per billion accuracy, even without external. So it's not good enough for what we would want to do, but it's remarkably good, certainly better than the Kiwis and the other devices that we've been SDRs. The clock and the 888 seems to be remarkably good. It's just a shame that we can't get a schematic of it. Because
Well,
it may-
say again who it was who's taken it, opened the device and found out where to hook up the GPSDO.
this is Glenn, N6GN, one of the
N6GN.
N6GN.
November. Okay.
Yeah, and he has a website, and
Are you talking about the RX 888?
we're talking about, yes, we're talking about the RX 888.
Because
Yeah.
it says it has an external input.
Yes, well,
Not on the case.
not on the exterior of the
Oh,
chassis.
it's not brought outside the case, but
You got to drill holes and
You have to drill a hole and make those, and you probably want to have a little bit of circuitry to protect it. Paul Elliott, WB6CXE, has made a modification for the QDX external clock input, and I bet we could, which involves a small PCB board and an SMA connector that protects the internal circuitry from any accidents on the outside. He has two versions of it, one that just passes through the clock, external clock, and another one that takes a 10 megahertz clocks and converts it to what you want internally. But that little adapter is for the QDX, but Paul is also working on the multiband transmitter and his for whisper transmitter, and he's been remarkably productive. So if such an adapter were needed for the 888, I suspect that Paul might be interested in spinning something out for it. So I think we could. I think that the more interesting, the more challenging question is really how do you synchronize inputs on a 888 where you don't have, you have common clocks, but you do not have a common time reference. And Phil's suggestion is the only one that I can think of. It seems quite possible you could, if you had I think doesn't the Tangerine RF section have a external noise source generator that could be switched into the input or something? And if something like that could be added, if only externally in front of the whole 888 and the RF signal path, if you had something that could, switch in between sample times and start injecting all zeros, all ones kind of RF signal, Phil could find it, and that would allow him to synchronize the signals, the samples, once they reach a main memory.
Yeah, I don't know the receiver. What we had planned to do on Tangerine was to, when we detected an edge on the pulse per second from the GPSDO, was to set the MSB in the data word for that one sample. And that gives quite accurate time marking across multiple channels, but you got to have access to the digital data stream.
Yeah, well, I mean, we'd have access to those because their signals going from well, I don't, perhaps that could be used in the in this design, the Tangerine. Have we come up with a name with the Tangerine for the USB 3 version of the Tangerine? I think, but
how about Clementine?
Yeah, Clementine. Okay, so, but if I will use that unless I think Nathaniel suggested it. So the Clementine would, I don't know if it would benefit from that feature of the RF board of the Tangerine. But if it did, then you have a unique sample. It's something to identify a sample, the time of a sample, and if you do that periodically, and you can even recover from errors in the transmission from the ADC output to the memory of the host computer. But I think this is a subject that I'm not the best person to recommend a solution. I'm repeating what I've heard.
And then there's another point I want to make, Rob, is that from the documentation, the Cypress FX3 cannot accept LVDS inputs, only CMOS. So it would have to work in CMOS mode, the ADC.
Yeah, it'd have to work in which mode?
CMOS, which is more susceptible to noise,
Oh, yeah.
not LVDS.
I believe that the ADDs can operate in CMOS is what Tom's been
Yeah,
saying,
it
but there's a
actually
significant
can operate in
penalty.
both modes. There's a bit that you set in the register, and the outputs will go from a DDR LVDS parallel mode to CMOS parallel mode. Because of problems with the Max 10, we had to kind of stop using the LVDS mode. So right now I program, when I'm doing the receiver module testing, they're in the CMOS mode. It's a 2 volt. The part's a 1.8 volt ADC. So the CMOS levels are 0 and 1.8 volts.
But there is an LVDS mode that you. So that would be part of the. Would that satisfy the requirement of the FX3?
Sorry, the FX3, as Tom said, is restricted to only use the CMOS mode, which is the one that is, the worst of the two, if you want to compare in terms of noise. If you could use LVDS, it would be nice, but you cannot.
Okay. I'm sorry, I missed that.
No, that's the context. Yeah.
Okay. Well, I don't know. Then we wouldn't really know that. Is there any error detection on the path from the ADC to the FX3? Is there parity bits or anything?
No, typically, at least in the RxX8, the connection is straight. So since it's 16 bits, it's perfectly because you get the 16 bits out from the ADC right into the FX3. There's really, 16 lines parallel that just connect the two together. There's not much else.
So there would be really no way to determine, well, in operation, there'd be no way to determine if there were an error in that transmission path. You'd have to, you could characterize it, right, with a known stimulus in developing it and see if there's a problem.
To avoid crosstalking on the 16 path, you can have in the LTC 2208, which is what they use because it's only $15, I think, over there. In that one, you can use something called dithering and randomization. Randomization. So with randomization, you get all the bits being randomized, so you will get a good, avoid problem of cross talking on those 16 connections. I mean, you're running only at 130 mega sample per megahertz, so it's not crazy high. If you keep it short, it's not too bad. And once you get into the FX3, it's all digital, so it's all taken care of.
Well, okay. Well, I mean, I think this is productive to understand where the challenges will be and whether we're. As always, the devil's in the details, but this is one detail that I wasn't aware of. But it doesn't sound like that it would suggest that we couldn't go down this path, that it isn't worth trying the USB 3 interface. Sorry, is that your conclusion, Franco?
Yeah,
and Tom, of course. Tom, you and Tom are the two.
Make the group aware of all the limitations, so there is least surprises later on. It's possible, since you have the RX88, to make some measurements of what would be the noise. What is if there is any problem, basically.
What specific FX3 is
the
it?
3014, I think.
14. Okay, I think 14. That's what I got. Yeah, the development board for that's not terribly expensive. I have one ordered from Newark in England.
Oh wow! Because when before the pandemic they were $47 each. Now I looked, you cannot find them.
This was 58. And
too bad, actually.
No, and it seemed pretty reasonable. But I had to go to Newark, and I had to go to the right site. I couldn't go to Element 14. I couldn't go to, there were lots of things I couldn't do. There are lots of them available in China, but they won't ship them to us. So but Newark in England had, and was at least claimed to be willing, was willing to take my money. So, which is, it took a long time. They have a god awful payment site, but I think I got that straight.
I mean, they have
Not
a
like-
very nice SDK. So if you get that down from Cypress/Infineon, you'll be able to do pretty much everything. And the firmware is all open source. So if you go in the repo I linked over in the chat here, you find all the firmware. And it's pretty much C, you know.
Yeah, yep. Well, I know it's not good to get ahead of ourselves in any way, but as I recall, that particular family of chips came out a good while ago, and
2010.
Yeah, 2010, and I would
2010,
expect, I would expect, you know, a USB 4 sort of interface from them sooner or later.
There is one, the CS6 SD. I can give you the link after here. I'll send you an email with that. Yeah, there is
Okay,
one.
that would be nice.
Yeah.
Yeah, because that, at least it'd be nice to track something like that, because that
Yeah,
would
yeah.
answer a lot of the questions about speed in the future.
On the timing thing, it seems like it'd be interesting to have like a subcarrier instead implanted that you were sorting out. You mentioned that Phil said he could sort that out later. In the UK Meteor group that's monitoring meteors, they're trying to do this sort of thing, mixing in a tone or an audible signal, I think, with their other RF that they're receiving. And I think to me, it seems like it'd be easier to get more accuracy across channels than a once per second kind of a signal.
Well, I think whatever the stimulus is and the comparisons, I think they need to be done at the level of the RF the samples, individual samples. So I don't think that you can get you know, phase accurate relationships between input from arbitrary RF signals. I think you really need some way, some fairly, you know, something that's at the speed of the sample rate to be able to identify the samples. I mean, you know, and to correlate samples. So, you know, injecting periodically injecting a full scale sample into the stream, or a series of full scale and zero samples into the stream, would seem to me to be, you know, a fairly straightforward way to communicate to Phil as he looks through the sample stream to identify these kind of this unique series of samples which would not otherwise occur on an antenna. And but I really shouldn't speak too deeply on this. I think almost everyone in this group probably knows more about these issues than I do.
Well, the GPS chips can be programmed for a certain frequency on their outputs instead of the once per second that's available. So it's not necessarily an arbitrary signal. It would be a synchronized signal from them.
That would be, yeah, if the GPS signal could be routed periodically to the input of the ADC. I mean, the one PPS is in a sense enough. If it's, I don't think that the U-Blox chips guarantee. I think that the resolution of the PPS is on the order of 70 nanoseconds, which is, you know, what's our sample rate? It's where sample rate's 10 nanoseconds at 100 megahertz. So, so the resolution of a PPS signal from a U-Blox chip is probably would limit the accuracy of synchronization, but you know,
You're going to want to run a PPS coming out of a GPSDO, not straight out of the GPS receiver.
That was part of Ackerman's design, though, was to try to get rid of that inaccuracy.
That's right. Yeah, but if you take it straight out of the GPS receiver, it jitters way too much.
So
But
that
we
be
should have
already
that in
built
our clock module.
Right. It
But
is.
these seem like less intractable problems than we were encountering with the FPGA path. And there seem to be a variety of approaches to them at this point. And it's also, the tools seem to be less expensive for exploring them as well. So there's room for work.
What's the first step forward here? You know, when we were designing the Tangerine SDR, there was a time where, you know, we went through building these requirements documents, and then there, I think Tom wrote some interface control documents, and then we saw some schematics. Like, where do we go with this? Do we have to rewrite requirements documents? Do we, what's the path forward here?
Well, I think some of this is in a data gathering mode about what's the realm of possibility. You know, what do we have right now, and what can we wish to fix? And once we get a little past that, then it might be time to write a proper requirements document based on what we think is possible. I think we just don't know enough quite yet on a couple of points about whether we, you know, what's possible, but we will very quickly.
Is there a definition of what the Hamstock community needs to receive? What frequencies or range?
Well, yeah, I mean, when I first came up with this, I wanted to have something that went up to at least 30 megahertz, and then, you know, maybe up a little higher to like, you know, 50 or 60 megahertz, because then you start getting into being able to observe sporadic E. So that's how we came up with the requirements for the Tangerine SDR. So if you look at the Tangerine SDR requirements, it basically says you're going to have a receiver that can receive up to 60 megahertz. You're going to have each receive module will have 2 coherent phase locked receive channel paths, and each of those are going to get time stamped when the sample is taken by the FPGA. And then these systems are going to be able to, you should be able to tie as many of these things together as possible, so that if you wanted 4 coherent channels or 8 coherent channels, or, you know, n coherent channels, you'd be able to do that by, you know, daisy chaining the clock modules together. So I think that's a summary of what the requirements are for the original Tangerine. So I'm not sure how much of that we can still salvage or still incorporate into this new design.
The only thing I heard you say that I don't think we can do here is that you were talking about the FPGA doing the time stamping. Obviously, there's no FPGA, so the time stamping isn't going to happen there.
Right.
So other than that, I don't think there's a lot of functional difference. I mean, in suggesting this, you know, path, my goal was to make it as simple as and look exactly like the Tangerine as much as possible, and to minimize any changes, and not let the better get in the way of the good, and the producible, and the, you know. So I you know, having developed products commercially for 30 years, I'm you know, there's always the trade-off between, oh, there's always going to be a better chip out there. There's always going to be a better way to do it. The question is, you know, I mean, I had one product I developed and we invested 2 man years in it, and in 6 months it was obsolete. You know, the day we were about to start to sell it, the successor came in that was 2 orders of magnitude or 3 orders of magnitude cheaper to do. So I, you know, there's always that possibility. But I think in this case, what we have seems to match, you know, apart from the time stamping requirements, you know, a bank of 888s are kind of doing what we want, and what we would get out of the RF section of the Tangerine's RF section is certainly I'm sure it's a better RF design. I mean, having seen what was thrown out there in the Kiwi SDR's Fly Dog Raspberry SDR world. I mean, these other devices, were garbage. I mean, they were just, the guys who designed it had no idea about RF. So I that doesn't seem to be the case in the RX 888, but lacking a schematic and deep investigations of it, we don't know its vulnerabilities. So I really like the idea of having Tom's RF section, because I trust that it will know it. We'll know where the chips come from. Who knows where these RX 888 chips come from? They could be harvested from anywhere. So we might get we might get batches that have a whole range of performance variations and imperfections. So that's why I think for scientific research we need to have the Tangerine RF section. But the rest of it, I think, is we should try to minimize the changes as much as we can and try to get this thing done and first generation out there. That's my perspective. But it's your project, Nathaniel.
No, I agree. No, I absolutely agree with everything you said. I just wasn't sure, what the way forward is. And I think maybe Dave Whitten said it best, is like right now we're in this kind of data gathering mode right now. And,
Yes.
Note that Franco posted in the chat a link to a GitHub site that does have a collection of schematics that are associated with this.
It's the first version,
Reversing.
I was just looking, this is the BBRF 103 site. Is that what you posted?
Yeah, that's Oscar Stala's BBRF 103, and there is a folder called hardware. Under that, there is the schematic of RX88. I put the link in the chat here. That's the version, the first version,
Yeah, there's a nice little block diagram in there too, as well as the schematic that kind of just lays out the components that are used.
Yeah. That one was the first version, which they published the schematic, but then the Chinese didn't publish schematic for the second version, which they made some changes to.
That's the version 1.
Yeah.
It's not version 1 of the 888. There was a 666 along there.
That one is not known who even makes it. The 888, we know who makes it, sort of, but the 666, another one.
But before the 888 or the 666 was this BBRF 103 by and there is let's see, blocks.
And I talked to the guy because he's Italian like me, so I spoke to him.
Okay, great,
to Oscar, but he's retired. He's now attending his grandkids, so we're still friends, but he's not really doing much now.
Well, this is very good. I hadn't seen the 888 schematic before, so this is certainly more than I knew about.
It gives a lot of what the thinking was. There's the 888, there's the 888, and then there's the improved 888, but they're pretty clear about what the difference is.
The difference is. Sorry, go ahead, finish, David. I meant to.
No, but I think there's enough here to make it pretty easy for someone to design one for Tangerine or for HP, for the ham side purposes, that is, has any added features that seem appropriate.
Yeah, a couple of comments, David. Oh, sorry, go ahead.
Go ahead. No, done.
Okay. So a couple of comments. The main difference between the two is that they improved the input stage. So they put an additional gain and an attenuator, which are not in the first model. So, but the core of the architecture is the same. The core is the same. The way they connect the LTC to to the FX3 is the same. That part hasn't changed a bit, and I think even the local oscillator, the SI 5351, hasn't changed much. That part there, they just
I
changed it
noticed
from
that they say they changed the tuner chip, but I presume that's only for the
the
VHF input.
VHF. That's the VHF. That's the Rafael micro tuner chip, which I think they use it. They now the R828 or something like that.
Yeah, it used
For
to
our
have the
kind of
same as the
purpose,
RTL
that's
SDR.
yeah. I don't think we care. I mean, we care. I don't think this group cares about the VHF. I mean, at least in this conversation here.
The,
The price is also about the same between the two, it looks like.
Yeah,
you think
just as a heads up, Glenn's measurements are that the Mark II's noise figure is slightly worse than that of the Kiwi, which is not very good. So the for 10 megahertz and above, like with the Kiwis, we're almost going to have some additional gain, a low noise RF amplifier, and of course, with that comes the problems of overload and, you know, how you deal with that and so on. So there's, there may be, if you're going to actually take this schematic and do something with it, there may be a reason to do some, you know, further design work. I don't know. It appears that whatever amplifier they chose is not particularly good for our purposes. I mean, all of the Whisper Demon sites that are out there now are running an extra 10 dB of gain in front of the Kiwis to get.
Rob, could you use an antenna that has a preamplifier built in? Some of the antennas have that.
Yeah, that's what Clint Turner, KA70EI, has designed a high pass kind of shelving filter. And we use that in conjunction with an LNA. So it's 10 megahertz, you know, it's a 3 dB point, or I don't know, maybe it's a 10 dB point is about 10 megahertz. So 10 megahertz and above, it rises to close to, you know, a pass through. But below that, it suppresses at 10 megahertz and below, it suppresses the input by about 20 dB. So anything that's going out in the field, if we want to make it kind of work well, I think needs to provide for such shelving filter and a low noise amplifier. Because I mean, I'm looking at a site up in Washington right now, and he's thrown up a dipole. He's out in the country, and he's, you know, above 10 megahertz, everything is the internal noise of the Kiwi. He doesn't have an LNA in front of it. So I think any decent receive site is going to need a better noise figure than, now I don't know what, as I recall, the Tangerine RF section did have something like a 4 or 6 dB noise figure. Yeah,
we estimated about 7 dB noise figure.
Yeah. And that's perfectly good. I mean, that leaves you, you know, with a, you know, that the ITU rural noise figures at 30 megahertz, I think, are at, you know, minus 160 or something. So if if you've got a 7 dB noise figure, you've got 6 dB of you know, padding. You know, you're you know, the antenna is giving you 6 dB more noise than your internal amplifier. But certainly this RX88 design and as like with the Kiwi, do not have those kinds of noise figure performance. And that was kind of why I think that there's a reason for the Tom's your RF section to be kind of the preferred way to get RF into a personal weather station, because either we're going to have to. I think that we're going to have to put band-aids around the 888 just the way we did around the Kiwi to make it useful on those higher frequencies, or we need to design our own version. And I think I'd rather concentrate. I mean, my perspective is I'd concentrate. You have a great RF section. Let's see if we can figure out how to get it to communicate with the USB 3 with that FX3. I mean, that would be my perspective, because the RF section seems to me to be a really important and not available elsewhere. That's
Yeah, when I looked, I mentioned in the email I sent to Franco that, a couple possibilities exist. One is, the 2 channels of USB 3 to get the data. Another possibility is to put a very simple logic device, like the old programmable array logic, the real simple fuse blown device or equivalent, to take the digital samples and format them in a way that the USB 3 chip could handle, maybe add time marking, but don't put on a CPU, don't put on a stack, don't put on all that stuff. Just put on, a couple of 100 gates worth of logic to format the receiver in a way that your peripheral chip knows how to deal with it.
Would that take
seems
care
to
of the
me
time
that-
stamping issue?
Yeah, it could also put the PPS edge and timestamp the data with it. But this would be something that's, not like a max 10, but something that's, a couple hundred or maybe 1,000 gates or something.
Back to the
I don't-
comment about how elegant it needs to be and the frequencies that are needed. The more complex it is, the more bandwidth that you need, and the broader range that you want to accomplish is going to drive a time schedule to a certain extent, I think. And the convolution, the ability for the software to do all the processing gets more complex too. So it might be good to just dumb it down to get where you need to be for your goals for this thing by the end of the year, and cherry pick those frequencies and say, we want to be sure we do well here.
One, that's probably true. One small point I wanted to just inject, it may be of no relevance. Unfortunately, Franco's gone, but there does appear to be some amount of programmability in the Cypress chip as well. It is an ARM chip, essentially an ARM9. I don't know what it's good for. They tend to overstate that in the documentation, or at least, and it's an old design, but there might be something useful that could be done there. I can't say.
Yeah, it's I looked a little bit at the data sheet, and it's I'm not as familiar with it with the other folks, but there's a lot of possibilities. I think it can handle 32 bits at 100 megahertz or 100 megasamples per second. And so there's a couple of options, real simple logic between it and the receiver. Right now in the FPGA, I take the data input and I bust it out from a by 16 to a by 32 in the Verilog to get the sample rate down. And you could do that with just a few gates of logic between the receiver and the Cypress part. It wouldn't even have to be programmable. It could just be some hardware gates that do all that function.
well. So what's the next steps here? Who's planning to do what? I wonder.
No, I'm confused. We have these receivers, which I didn't see any information about until tonight, and then the Cypress chip. And I'm not sure between all of these devices what direction we're trying to go.
I think that's the question I was trying to ask. Like, yeah, what is the next step? Is someone going to lay down a design? Is someone who's going to take responsibility for doing the next like actual thing? I know Dan and Dave said Scotty might, which would be wonderful, but I haven't seen. I know Scotty's been quite overwhelmed with his house arrangements. So I'm not sure, who would be the right person to do this.
I would be willing to do, just to shepherd the process of getting a requirements document together. Once we're ready to do that, just do the routing and make sure everybody sees it.
Yeah.
I'm not sure that I'm the person to pass judgment on all the pieces, but others are, and I'm happy to work on that.
I can also offer Majid's help. He's not a RF engineer per se, but he is an electrical engineer, and so he would, be available to work with people, and he has time to lay out designs, and so, and I think he's done a good job with helping out with the magnetometer as well.
Yeah, he's a joy to work with.
Yeah. So I mean, if you wanted to work with him, David, maybe that's a good way forward.
That would suit me.
Okay. What do you think, Tom?
I'm sorry, I'm trying to grab the mute and the links to the receivers.
Sure.
Yeah, I'd like to focus on trying to get the existing RXM working and characterized. And then, we can uncouple that board from the current project. And if it's useful, use it on, some new interface. That would be great. I'm not familiar enough with the RX receivers to know anything about them yet, but I'm real encouraged by having, a USB or maybe in the future a PCIe interface or whatever comes along from chips, and have that, kind of, we could plug in different kinds of receivers to that, and the plugging in the receiver might take a couple logic adapter gates, or maybe it goes straight in. I don't know, but I don't know how long it's going to take to get the RXM characterized. The Tangerine system makes this a kind of a slow going process right now.
So when you say you want to get the RXM characterized, you're still planning on, working with the data engine adapter and trying to, solve the FPGA problem?
I'm just enough to make measurements on the receiver module. So that we know, does the receiver meet the specs we think it has, and does the hardware work? And if it does, then we can plug that module onto some new interface. That's much easier to program, doesn't involve the Max 10, doesn't involve the Cordis tools. But right now, the only way I have to measure the receiver and make sure it works is to use the data engine adapter. I don't have any other tooling that I can use to characterize the receiver.
Okay. If once you do get to that point, do you think you might get to a point where you do think it makes sense to go forward with the FPGA approach, or is that just an unknown or what?
I think it's going to be very difficult to go forward with the FPGA approach.
Okay.
In turning that into a usable system is going to require a horrendous amount of software, and stacks and all kinds of things. And I'm currently fighting so many problems with the FPGA. I think, we got the clock module up to the point we verified it worked. It meets a lot of the specs. If we can do that with the RXM, then we have two boards, the clock module and the RXM, which can be used as pieces on a toolkit for something else.
Right.
And so I'd like to try to continue that.
Okay.
However, I don't think that the data engine is going to be anything that we can go forward with without having a huge staff of engineers to do it.
Okay. Okay. Sounds good. So then, so you're going to keep working on characterizing the RX module.
Yes.
Just using a minimal system with the data engine adapter.
Exactly.
Great. And then Dave, I'm going to have you work with Majid and whoever else you want to work with on trying to lay out some sort of a design or take a first stab at how this should go with the USB interface. That sounds great. And then I can also tell you that Majid, he has access to some of the funds from the grant for like buying parts or, prototyping boards or stuff like that. So he has access to some resources. So, and then is there anything else that any of you think I should be doing or I can do to help?
Well, I want to ask if I should contact Majid or if you'll speak to him and have him contact me or
I have a meeting with him tomorrow morning at
okay.
10:15. So I can talk to him then, and then we can send you an email. So
yeah, that'll be great. I'll be watching for it.
So I'll talk to him in person then. Yeah.
Sure.
And then what I'm gonna have my students do, and Majid is also supervising these students. And Kung is one of the students, and then there's a couple of students you don't know. Their job is basically going to be take one of these RX888 systems with the KA9Q software and turn it into a a 4 or 6 channel grape. That's what their job is going to be for the summer.
Well, that sounds like it would be, illuminating to pursue that path as at the same time. So
yeah,
we'll
because
learn some things.
Because Rob said that we can use his system, and then we're also buying our own hardware. We can do the software development, concurrently. We have a use case for the GREEP type of observations for the Eclipse project. So making those observations and getting them to actually go into Bill's system will actually be like have a definite concrete use case that we can use right away. So it won't just be like, oh, what are we're just making these measurements to make these measurements. Like we actually will have a purpose for them. So
is this so you part of that would be figuring out how to kind of manufacture or remanufacture 888s into GPS disciplined devices.
Well, that could be part of it. I mean, the first part would just be getting the software to to basically put out the data in the right format. And then if it's GPS disciplined or not, we'll just make sure it's compatible with the right format. And then if we can GPS discipline it and actually make it the RX888 a useful thing, fantastic. If not, then we just keep waiting for the Tangerine SDR or the Clementine SDR or whatever it's called.
And at least we know then what we need to spec.
Yes.
And it would be nice to communicate with Tom and Rob also on the spec thing as we go along it, as much as they wish to
just let
participate.
me inject one item of information for you, Dave, and also Nathaniel. I have read in a few minutes that it is said that the RX888 is compatible with HPSDR. If that's true, I already have code that will output the data in. I have a version of HPSDR with code that I have added that outputs DRF data in the format that we are already using. So don't have to sweat that.
So then that bypasses the KA9Q software, right?
It becomes a single channel receiver at that point. So it does work. Yes, and Glenn reported this morning that he had tried his 888 both with HGSDR, but he was pursuing using the SDR console, which he found more useful for his investigations. But those are the two kind of user interface GUI receivers software stacks that work with the 888 already.
So the problem with Bill, you said it was compatible with HPSDR, you said?
Yes, it is.
But only for a single channel.
you'll only be able to tune it to, the way the HDSDR tunes it. So it will tune it to a single whatever, band you're looking at. And that's all, is my understanding, that's all it'll do. So if you want to benefit from Phil's software, you're not going to get there right now through HDSDR. It would be a great project for someone to write an interface that allowed 888 to talk to HDSDR or SDR console or whatever. I don't know if there's the SOAPy SDR API. There's let's see, I think that AirSpy has a server API that they implement. I went down the path to SOAPy a little bit, but not very far. It's perfectly useful. So you could, if you had such an interface, you could go to, you could go to HDSDR and say, here, I want to talk to this server. Oh, okay, I'll talk to the one over at AKFS or KPH or, Maui. You could just tell HDSDR where the RF stream, the demodulated RF stream comes from. And that would be, I think, would make this project of interest to a far wider audience than us, radio research, ionospheric interest types. But
so
it's not necessary for what we're doing, but it would be another approach. You could run 5 instances of HDSDR, each talking to at a different channel and outputting to I guess a different virtual audio. I don't know how how HDSDR uploads, but you could do that approach, which would offer, I think most of the benefits would come to other users, but on the other hand, it might bring them into our area of interest, have it easy for them to relate to it. Yeah.
But I think SDR was adding some functionality.
But the big advantage of the KA9Q is that it lets you have a near arbitrary amount of near arbitrary bandwidth slice receivers, right?
It's one of its greatest. Certainly, it's the most unique. Its most unique property is that the ability to listen to hundreds really of channels off of one RF input.
And that's really what we want to, take advantage of with the personal space weather station architecture.
Yeah, but so what are those clients in the personal weather station? What are the destinations for the demodulated audio? I mean, it's going to the grape to interpret it to grape and upload to grape. Where else are you thinking of? What other kinds of clients are there for the K9Q radio daemon?
There's the chirp sounder, that takes 20 megahertz of bandwidth. So there's that.
Okay, well, that's certainly
that's one. And then of course you also have all you want to do your whisper decoders.
Well, that's that I'll get working on my own, whatever. I'm working with Phil on that one, so I'll take care of it.
Well, I've also seen some projects for monitoring the carrier frequency of a wide variety of different commercial radio stations, which can be used both to study Doppler shift in the ionosphere, but also to watch for meteor impacts, which produce pings, which you can see superimposed on those carriers. And there's a few other things that we can think of.
Oh, good. Well, I just said, thinking of each one of them, it's pretty, each one of them can get all you have to do is open a multicast address and subscribe to a multicast address, and bam, you've got a stream of audio across, in IP packets. So
now one thing there are many things I don't understand, but one of the things I don't understand with this multicasting, Dave Larson was saying that you have to have a multicast switch in this system?
Well, multicast packets are, have 3/4 of the way to broadcast packets.
Right.
Yeah. Okay. And so inexpensive routers that you buy at home, the $20 routers, don't understand that. So what they do is they just treat multicasts as packets that come in as broadcast packets, and there's an RFC that defines the translation between a multicast address and the Ethernet MAC address, a broadcast Ethernet MAC address, or I should say multicast MAC, the layer down. And so the switches can say, okay, this is a MAC address, an Ethernet MAC pack, the whole Ethernet packet. It has a multicast address. I don't know how to deal with that. I'll just send it to every one of my ports. So multicasts become broadcasts, and this will bring a Wi-Fi router to its knees. Okay. So,
yeah, but you really can't run this stuff across Wi-Fi.
But
in any
no,
case.
no, no. Of course not.
I guess what I'm saying is, let's just say, can you have an architecture? You have our Clementine SDR or RX888 going into the USB of a single sufficiently powerful computer, and all the packets stay within that own computer.
They can, or you can play, or other devices connected to that same to the Ethernet switch,
right?
Can subscribe, and if the Ethernet switch is,
but if
costs $80 instead of $20, it'll do what's called IGMP snooping, and it'll listen for these multicasts and delivers them only to the people who want them.
But you can have a system where you have everything stay within a single computer, and you don't use the multicast at all, right?
That's right. That's right.
Okay.
The multicast won't go out the Ethernet port
unless someone subscribes to it.
Unless somebody asks for it. Yes.
Okay. And I guess that's where Dave Larson was telling me that you absolutely had to have a multicast switch in order to make this thing work.
That's not,
I
not in
think
that
I
sense.
thought
No.
the idea was if you overburden the computer you're working with,
Then
you
you could offload it to other computers, and then you would want the multicaster.
Yes.
Okay.
Yes.
Right. And so I think that was something that Dave Larson did not understand. And
he understands it, but he's not stating it. He's stating it from the perspective he's trying to use it.
Okay.
And I think it's been muddled for a long time between him and me as well. He's been trying to get me interested in this for over a year, and I couldn't quite see what he was getting at, but now I do. But yes, you can essentially, it uses the IP stack, the TCP IP stack, for all interprocess communication. So it just runs everything up and down that, instead of using like local sockets or something, because it's very modular. And but it uses multicast around the local wired network. The data then can go where it needs to via any means, by passenger pigeon out from those things. But and into a bigger data collection scheme. But yes, you kind of you scale your plant, your local plant, to your needs.
That sounds very, very, very attractive. Yeah.
It's wonderfully modular. The only place where I think Phil has recognized it's not appropriate to be multicasting is when we're using multicast from the USB 3 stream and internally inside the Phil multicasts everything, including the raw sample stream gets multicast inside the computer. Well, there's only one subscriber. There's the radio dean listening to it. There's, yes, you could have multiple radio Ds, but that wouldn't really gain you any functionality. So that's a very expensive. Multicasting is, in any TCP communication, is much more expensive, CPU and memory bandwidth wise, than simply DMAing into memory and having a shared memory space. So one of Phil's projects is to modify his code so that he doesn't multicast the raw sample streams. He DMAs them into memory. At which point, I would expect the CPU utilization to go way down from what it is right now. I suspect the largest portion of his 35% of the CPU cycles in my computer out here at KFS, that largest portion, I would bet that a half or 2 or 3/4 of that is just copying multicast packets around within the same computer, and only a quarter or a third of the CPU cycles are actually spent on the FFT of the raw sample data. So there's the multicasting is a wonderful tool. I mean, I built my whole professional career around it. IPTV is based upon multicasting, so there's lots of good things about it, and he's used it, a little bit overused it, but hardly. It's not a big deal. I mean, it's something. I'd rather him work on other things. Phil work on other things first, rather than getting rid of all those memory copies. And
as you push the requirements of the computer, though, you start to lose some of the community people, because I remember early on in the DSP projects, the people complained that they had to buy faster computers. Well,
the computer that's running on right now, it cost me $120.
Right.
It's a refurbished i3, Lenovo i3. It looks like brand new, came through eBay, 1-year guarantee. I mean, I don't know that computer can handle. I don't know its internal USB 3 architecture. So that would be an issue. I don't know if you can add a second USB 3, running at 4 gigabits. You'd need a separate PCIe lane to do it. And I don't know that it's. I don't know the internal architecture of this device, but I found one USB port that was 3-port that did allow it to pump the raw sample data into memory. And
I'm just pointing out that you're going to hear that from the crowd later.
Yeah.
Well, they'll have lots to say.
Everybody want to use their Pi to start with.
Yeah, well, that's it. If they want to use their Pi, they probably could if you wanted to limit it to like 10 megahertz. Phil has it working with has been using it with the AirSpy HF Plus Discovery for years, and he's with he's using RTLs, I think, on the higher frequency, so maybe that's a 8-bit sample device, but he can do a 10 megahertz on an RTL and demodulate 200 channels of FM.
Well, every ham has to go to now. There's truckloads of refurbished laptops that are still probably pretty capable because they've been taken out of service, but there's probably pretty powerful machines that you can get for a nominal fee.
Yeah, I think that there's that the major cost of our RX 888 system is the RX 888. The rest of it is, and the Bogner, if you want to, or whatever you want to discipline it with. The PC is probably, most people have one sitting in the corner and they're wondering, well, what to do with it. So I actually bought this for a different project, and then when Phil came along with the 888, I said, okay, this is what I'm going to use.
I got to go, guys. Nathaniel, I'll talk to you at 8 a.m. Central.
Great. I guess I'm going to say 73 as well. Thank you very much.
Okay. Well, we have action items out of this? I guess, Dave, you might be looking into the FX3 and the USB part.
I am certainly going to do that. Whether I'm going to be the expert on it that Franco is another question.
Okay.
But at least I want to be conversant with it.
Well, it would be helpful. I think I was very pleased to see Franco here. I think to the extent we can make this project easy for Franco to support, I think that would aid us all a lot, because I think his familiarity with drivers, Linux drivers and USB 3 drivers, it's not a skill I have. And I don't know if there's anybody else in the group that would have it. I mean, one could always learn, but you've got a great resource in Franco. So to the extent we can minimize the burden on Franco, I'm sure he seems eager to help, but I do know, he has a full-time day job, so his availability has been, we shouldn't presume on it. So that would be.
It sounds like the Hamvention had the impact on this project that it's had on a lot of other projects in the past.
Yeah.
And Dave, I thank you very much for being willing to work on this and help out with that part. And
Okay, yeah, I'm happy this is much closer to the architecture that was kind of.
Yeah, I was going to say, I've forgotten about this, but Clint Turner, AA70EI, has a blog page. He has been working to integrate the with the 888. And it would probably be good to point the group, Nathaniel, point them to Clint's webpage, because he has all the questions he's answered and a whole list of questions that are unanswered that he would, he'd like to learn about the 888.
Which page is this?
I'll send you Clint's blog page, and maybe you could share it with people. And I think I've encouraged Glenn, who is doing more, complementary work analysis on the 888. I think Glenn will be posting something up. I know he's been writing to our group some emails on what he's learned about the 888. So I'll talk to Glenn. I did suggest he put it up in a blog post so that those are, that it was available.
That sounds good.
Okay, so that would be a resource and a place to start. And I'm sure Clint would be very responsive to, if you want to ask questions or tell him what you learned. I think he'd be very grateful.
And I will probably not be here next week because I'm taking a good number of students and a few faculty members down to Virginia Tech next week on a road trip. We're going to be spending the week working on super darn data there. So I'm going to be working on an intensive week there.
Okay, well, that's understandable. Well, I hope.
What's that, Dave?
Oh, I was just going to say you need a commercial bus driver's license.
I know I think we're renting 2 minivans.
Yeah. The week after that, I'll be in several weeks. I'll be away in Europe. There. I was going to give a presentation on the transmitters.
Good luck with that.
High stability. Well, it's basically what I presented at the workshop. But anyway, I just like to. Hopefully, this project can move forward and fairly. If I can help undo roadblocks, I'm happy to help. But I don't know that I can do. I'm not a hardware designer, and so I can't help on that part of it. Did Dan didn't attend? So Ackerman.
John Ackerman.
John.
Yeah, he said he's usually not able to attend the nighttime meetings.
Yeah. So, is he is he a candidate to work on the hardware design?
Maybe.
Or was it going to be Scotty?
I think let's go ahead, Dave.
Let's see what our requirements look like.
Yeah.
And cast about for who's available as we do that. Because we just don't know.
Okay.
Yeah.
Doesn't look that hard.
Yeah. And it is something, again, it is something that maybe when you're talking to Majid, it may be something you can either Majid or even the students can take a whack at.
Yeah, I would really like to talk to Majid about it for sure.
Yeah. Okay. Yeah, I will definitely tell Majid and we'll be in touch with you tomorrow then, Dave.
Okay.
And you're welcome to sit in. I can send you an invite for the meeting tomorrow morning, but I think the meeting's probably going to be, well, would you like to? The meeting.
What time is it?
10:15 Eastern AM.
Okay, okay. I might be able to make it. Yeah.
Yeah. So the meeting, I'm sending you the invite now.
Okay.
I'll
do
yeah,
my
the
best.
meeting is really to get everyone on the right page for their different projects. So that it was originally going to be more of a software discussion, but I think this will give us a chance to kind of sit around the table, find out who the team members are, and then figure out what people are going to be doing.
Mhm.
Okay.
Well, great.
Thank you, everyone.
Thanks.
Good evening.
Take care.
Have a great night.
Thank you. Thank you. Bye.
Bye.